Snowflake says that the cloning is a quick and effortless. Yes, it is technically. However, there are a lot of ifs and buts when clone operation is performed, and it is always not that easy as you expect it to be. As you know, we can clone tables, schema, and databases. Let's say you want to clone a database. Database may have one or more schemas, and each schema may have many more objects like tables, file format, sequence, stream, task, and so on. There will be roles and grant too associated with this object. And you can think of many questions like, is it possible to exclude some of the objects when cloning operation is done at database or schema level? What happens to the file ingestion metadata with pipe and copy commands? What happens with unconsumed stream data? Can transient and temporary table be also cloned? What happens to unnamed stages? What happens to the table which has reference to a sequence object? And many more never spoken rules, including time travel feature applicability with the clone feature. So, welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake data professionals. The last 14 episodes in this series already covered from history to architecture, bulk data loading to continuous data loading, unique Snowflake features to multi-cluster virtual warehouse, micro-partition concept, time travel, and many more important discussions. This episode, the episode 15th, will primarily focus on zero copy clone and understand its power and limitations and its applicability for each schema level object. We will also discuss the limitation for each of the object type, including time travel applicability. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all the concept listed in this slide. So before we start, many of you really like this tree map approach as it keeps us focused without wasting any time. So let's quickly review it. The chapter 15, the zero copy clone, majorly divided into 5 sections where we'll understand what is a clone and a snapshot, including its limitations and consideration, plus SQL syntax. We'll jump to the table cloning and understand how the table cloning really works, followed by schema and database cloning and its consideration, copy metadata as well as clone concept, plus clone with history and task. Before we move to the next section, I have an important question to ask. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I think you should be. There is a lot of great opportunities out there if you know Snowflake Cloud Data Warehouse. I have been adding a lot of videos to help the Snowflake community to learn Snowflake besides Snowflake certifications. The feedback I got from my audience way high than my expectations. Folks are getting certified at first attempt and scoring close to 100%. Data engineers, leads, architects, and even data managers are learning from my free content. You don't need to buy any expensive courses. Check my playlist. It includes complete hands-on Snowflake guide, Snowpro certification guide, important mock questions for certification, key SQL function series, Snowflake Python and connector series, and many more videos are on your way. So press the like button if there is anything valuable in this video for you. Cloning, also referred to as zero copy clone, creates a copy of database, schema, or a table without having any physical copy from the source object, and that's how it is called zero copy clone. It is a point in time snapshot of data present in the source object. It could be database, schema, or a table. Is taken when the clone is created and is made available to the cloned object. The SQL syntax is very simple, and by using the clone keyword, you can create a cloned object. Since it does not copy any physical data, the clone works instantaneously no matter how big the database, schema, or a table is. We will try creating a table using a clone versus create table as a select statement and see it live during the hands-on session later in this chapter. Let's understand clone versus snapshot using a visual representation and underlying physical micropartition concept which we have covered in chapter 13 in detail. We have a time horizon. We have a customer table and we can say it as a source table. At time t1, we clone the customer table and make a cloned table. The cloned table is a point in time snapshot, and under the hood, it refers to the same micropartition physical files of the source table. So right after the clone, both the objects are exactly same. And when the query is executed on the clone table or even at a source table at time t1, they refer to the same micropartition. Let's assume that the source table is from production environment and the cloned is made to the non-production environment for debugging purpose. As we move further in our timeline dimension, the prod ETL made some changes to the customer source table, and at the same time, the development team has added, deleted, and updated some of the record in the clone table. These actions create separate physical files post-clone, and these operations are completely independent. After the changes are made to the cloned object as well as in the source object that make this table unequal. So you can say that the cloned object is a writable and is independent of the source object. Changes made to either the source object or at the cloned object are not part of each other. Let's understand which all objects can be cloned and gets cloned automatically when the database or schema objects are cloned. So when you clone a database using clone keyword, point in time snapshot is created without making any physical copy of actual underlying data for that database. All the schemas under the database is also cloned. All the objects listed above, permanent tables, file formats, sequence objects, name external stages, pipes, stream, and tasks are also copied along with the schema. When it comes to the database cloning, the roles and grants, they are also cloned for a child object, means for a schema or a table level. However, the database level grants and roles are not copied. So in this case, schema and all other objects under the schema grants will be cloned, but DB grants will not be cloned. A very important point to remember. Let's revise list of clonable objects. These are the 8 objects which can be cloned as per the Snowflake documentation. However, if you clone a database or a schema, there are many other objects which belong to the parents will get cloned automatically. So there is a difference between what can be cloned and what gets cloned automatically from the parent object. Users and user role cannot be cloned using clone keyword, and there are many other account level objects which are not candidate for cloning. This is very important for your Snow Pro certification. Follow the link above. We will see some interesting behavior about transient and temporary table during the hands-on exercise. Enough talk and theory. Now open your Snowflake free trial edition web UI or Snow site and let's learn together and have some hands-on exercises. So I am here in my Snowflake's web UI and let's start playing with clone feature. I'm going to create a simple order table. My order table is created successfully. Let's populate few thousand rows in this table using a select statement. So 100,000 rows got inserted. Let's validate the data quickly. So this is an order table with order key, customer key, order status, total price, order date, and order priority. Before we clone the table, let's perform one delete operation so we can also validate the time travel feature alongside. We have seen this in episode 14, but I would repeat it. So I'm going to delete order key between 30 to 40 and let's see how many record gets deleted. So total 8 record got deleted. I also recorded the statement ID. Now we will create a table called simple order clone using a clone keyword. So SQL syntax is pretty straightforward. Here we see we are using a clone keyword, and here I am creating a clone using a simple order permanent table. My clone is created successfully. Now let's check the table count from both the table. This gives me 99,992 because we have deleted 8 record. The clone table should also give the same record count. So I corrected the table name and it is again 99,992 and this is expected. Now we would like to ask a question. Is it a zero copy clone? To identify that, we need to check the information schema table dataset. Let me run the information schema table for you. And this is how this looks like. Now let me execute the query with table name and schema name. Now I got 2 tables. Here you can see I have a simple order, which is the primary table or a source table. Then we have a simple order clone, which is a clone table. I can see the row count for both the tables are same. And the bytes on this table is also same. The retention time is also same. So everything looks exactly same for both the table because it is a point in time snapshot. Remember, the table name must appear in uppercase because in Snowflake, everything is stored in uppercase unless otherwise you have specified with a double quote. Now let's check the byte fields in the table storage matrix view. To access this view, we have to use the account admin role. Let me verify. Yeah, so my role is account admin. Let me run the query on the table storage matrix and filter the table name simple order and simple order cloned on my schema ch15. I can see I have a clone table and I have a source table through which this clone is created. For the clone table, my active bytes are still 0, and for the source table, which is simple order table, here I have active bytes. Since we had performed some delete operation, I have data available for my time travel bytes. So this proves that when you make a clone of an object, at that point of time, there is no physical data movement or copy has happened under the hood, and it is just referring to the physical partition file of the source table. However, as we have seen in our slide, as you start making changes, the simple order clone will start getting some active bytes. Now let's make some changes independently and validate the behavior. So I'm switching back the role to the account admin, and I am inserting 1000 rows into the simple order table. So 1000 rows got executed. Don't worry about the duplicate rows. This is just for validating the clone feature. Now on the clone table, I am performing some update operation. So I see roughly 20,000 rows got updated. Looks good. Now we will check again how my information schema looks like. Here if I look on the order table, I have got a different row count, but in the clone order table, I still have 99k records. So bytes are also changing. So if I go and validate my total storage matrix, this will show me a different number and the clone table will not have the 0 values. Before I run the query on the table stage matrix, I would change my role to the account admin. So my role got changed successfully. Now let's run the query using the filter criteria table schema equals to 15 ch15 and the table name either simple order or simple order clone. And now we can see this active byte has changed from 0 to a new number. Right after the clone operation, both the tables are referring to the same partition. However, after that, the cloned object is a writable object, and any changes done on the cloned object will have its own partition files and its own storage. Next, let's see how clone works with transient and temporary tables. First, we will create a transient table for the order data. Our table is created successfully with the name trans_order. I'm going to populate 100 rows in this table. Let's validate. Now let's clone the table using the trans_order table, and I'm going to create a permanent table from the transient table. Is it allowed? Let's see. It says transient object cannot be cloned to a permanent table. It means when I clone, I can only create a transient table from a transient table. Let me execute another SQL statement. So my table got created successfully, and now I can see. I can see I have a trans order and trans order cloned, two tables with exactly 100 rows and 3584 bytes. Now let's see how temporary table works. I am creating a temporary table called temp order. My temporary table got created. Let me populate 100 rows in this table. Let's quickly validate the data. I am cloning temp order cloned from temp order. So I cannot create a permanent table from a temporary table. Let me clone the temporary table to a transient table. Is it allowed? Let me try that. Yeah, I managed to create a transient table from a temporary table. So you cannot create a permanent table from the temporary and the transient table. However, from the temporary table, you can create a transient table using a clone keyword. Now I'm going to create a temporary table from a temporary table, and I assume it should be allowed. So I got my two clone table created from the temporary table. One is the transient table, another is a temporary table. However, permanent table is not allowed from your transient or a temporary table. So here I can see I have a temporary table and I managed to create a clone table from the temporary table, and I also managed to create a temporary table from the temporary table. So this is the cloning behavior on transient and a temporary table. Can I create a transient or a temporary table from a permanent table using the clone feature? Let me try that. I'm going to create a table called permanent to trans, which is a transient table using a clone feature. And second, I'm going to create a temporary table named permanent to temp using a clone feature again, and for that I am referring my source table as a simple order table. So it is created successfully. This is also created successfully. Let me check that. These two tables are created and they are temporary and transient table, and they are created using a clone feature. So permanent table can be cloned to permanent, transient and temporary. However, the transient and temporary table cannot be cloned to a permanent table. Let's understand how the object dependency works when we use clone feature. Here, in this case, a table is referring to a sequence object which is primarily used to generate a next value. So I'm going to create a sequence called event sequence, which is start with 2 having an incremental value of 2. My sequence is created successfully. Next step, we are going to create another order table having a sequence as identity object. Here we are creating an object dependency within the same schema. Let's populate 100 rows in this table. Let's validate the data quickly. So I'm having a sequence ID starting with 2 and it is jumping with 2. Now I'm going to create a clone table which is called order sequence clone and using order with sequence. So this is how I'm cloning a table, and that table having a reference to the sequence object. Let's see, does it work or it throws an error? It worked perfectly. Now how do I know whether it has copied the reference correctly or not? For that I am going to use the getDDL function. Here I can see that it has copied the sequence object reference properly. Looks good. However, if your sequence object belongs to a different schema or a different database, make sure that you validate that this table has a usage access to that sequence, and that has to be created manually. The clone doesn't do it if you are cloning the table directly. However, if you are trying to do it at the schema level or a database level cloning, this will happen automatically as long as the sequence object belongs to the same database but maybe a different schema. In that case, your grant and role will work properly. Now let's try to insert some extra record into the cloned object and see if the sequence is working properly or not. So here I am inserting using a select statement. So since it is incrementing by value 2, adding 50 more rows will make the incremental max value as a 300. And I can see the maximum value is a 300. On the other side, the source table is still having a value up to 200. After the cloning, both the objects become independent and internally they might be referring some part of the partition data from the same partition file, and we have understood in our theory slides. Next, we will see how cloning behaves when we try to clone an external table, and for that we are going to create a stage, a file format. We'll create an external table by mapping that stage using the file format, and we'll try to clone it. So let's create an external stage first. So my external stage is created successfully. Let's see all the files. I can see that I have 4 files available in my external stage. Now let's create a file format called csv_ff. So my file format is created. Now I'm going to create an external table using this external stage. We have covered the external table in the chapter 11. Refer the link above. My customer external table is created successfully. Now let's see the customer data, because it will simply refer to the external stage and get the data. I got 4000 rows into the external stage. Now I'm going to create external table as a permanent table. Again, this operation is invalid. If I try to create an external table from an external table, hopefully it will work. So this also doesn't work. And what Snowflake says that following object types are not cloned: external table and internal Snowflake stages. So this cannot be done. So can I clone the external stage? Is it possible to do that? Let me try it. So I'm going to clone my stage S3 and going to create my stage S3 underscore clone. It says it is created successfully. Let me show all the stages. And here I can see I have two stages and they are all available in my US East AWS region. Now let's try to create an internal stage and see whether clone works or not. I created an internal stage. Now I'm going to use clone function to create a clone stage. It says cloning internal or a temporary stages are not supported feature. Maybe in future it will support, but at this stage it doesn't. If clone function works with sequence and file format objects. So let's see how many file formats do we have. So right now I have only one file format called CSV_FF. I'm going to create a cloned file format using a CSV_FF file format. Now my clone object is created successfully. Let me see all the file format. So I can see that two objects are there. One is cloned and one is a source object. File format really does not hold any data. It's very easy to have a clone. Let's see how many sequences do we have. So we have only one sequence with a next value 302 and interval 2. Let's create a sequence object using a clone function. So this is how it looks like. I have two sequence objects with exactly same next value and the interval. If I run this next value with select statement, it gives me the exact same value. Now I'm going to alter the cloned sequence object and change the increment from 2 to 3. Let me see all the sequences first. This is how it looks like. Both of them 304 and 304. So the first is a clone which will increment by 3 and the second will increment by 2. So one of them will get 305 and one of them will get 304. It changes after first run. So I was expecting, since I have executed the alter statement, the very next statement should change. What does it mean? That sequence object already holds the next value. So very important observation here. Next, we will see how the cloning function works with the pipe objects. To have a pipe object running and making eligible for a clone, we have to quickly create an external stage, set up a file format, create a pipe, and associate a copy command with the table. So I'm creating my external stage. So my stage is created successfully. I'm going to create a simple file format called CSV_FF_pipe. My file format is created. Now since my file format is created, my external stage is created, I would like to see the data. So I'm able to access the same 4000 rows which we have seen in the earlier section. I'm going to create a customer pipe table. This is a permanent table. My customer pipe table is created. Before I really enable the pipe, I would like to see the copy command, whether it is working or not, with the stage and the file format. So the data is loaded successfully. Okay. Now I'm going to create a pipe called customer pipe, and auto ingest is true. And this customer pipe will have a copy command as we have tried in the line number 44. So my pipe is created successfully, and let's check whether pipe is running or not. So the pipe is in a running state. Now I'm going to use the clone keyword to make another pipe named customer_pipe_clone using the customer pipe as a source pipe. So it says the cloning of the pipe really doesn't work. Okay. So as we have seen in the other slide, we cannot really copy the pipe. Let's try. If I copy a schema whether my pipe is copied or not. So for that, I'm going to create a schema called ch_15 underscore cloned, and that schema will copy the ch15. It took roughly 7-second time to really copy the schema. And now my customer pipe, which is a source pipe, should be available in this schema, and let's run it. So when I see that my pipe is copied as the schema as a parent object is copied, and it shows that its status is stopped clone. So how can I make it running? So if you run the alter pipe with the name of the pipe along with set pipe execution paused equals to false, it will make the pipe resumed. My SQL got executed. Let me check the pipe status under my cloned schema. Now my pipe is having a running status. The pipe cannot be cloned. However, when you copy a schema or a database, the pipe gets cloned automatically and the status automatically set to stopped clone. You have to run this alter statement and set the pipe underscore execution underscore paused equals to false to make it resumed. Next, we will learn about stream objects and how clone behaves with stream object. If you are not sure about stream object, don't worry. We are going to cover the stream object in the future chapters. And here is a link where you can really understand the stream and task in detail. This is one of my most popular video. Let's create an order table. Let's populate 100 rows into this table. 100 rows are populated. Now I'm going to create a stream object. This stream object captures all the insert, update and delete operation as a CDC. So this is a syntax called create stream, the name of the stream object on order table. So my stream is created. I can see I have a stream object available. Stream objects are nothing but a kind of a delta table, and any operation performed on your order table, it will capture all those add, delete and update operation. Now again I am inserting another 10 rows into my order table, and this 10 rows will be captured into the stream object. So we got the 10 rows inserted. Now let's see our order table. It should have 110 rows. Now the stream order table is a delta table. It will have only 10 rows. Perfectly fine. Now I am going to create a stream object using a clone keyword from my stream order table. The name of the stream object is stream order table underscore clone. Now my stream object is created via a clone keyword. And let me see whether it is having that delta available or not. Yes, it has all the delta data available. However, if your delta data becomes stale, and on that state, if you create a stream object using a clone keyword, that stale object may not be accessible to your newly created stream object via clone keyword. So this is how the clone and stream object behaves together. Next, we are going to talk about task and how the clone works with the task object. If you do not know what is task, we are going to create a task in the future chapters. You can schedule an SQL statement running on a certain frequency, and the task is nothing but a wrapper on the top of that. So here I am creating a task called create or replace task. It needs a warehouse. So I have given a compute warehouse. It runs in every 60 minutes. And it runs a SQL statement called select current user. I can also call a stored procedure, or I can write another complex SQL statement here. So let me create this task object. So my task is created successfully. To resume the task, I need to have certain privileges. Right now for simplicity, I am switching my role to the account admin, resuming the task, and again going back to the system admin. So my task is resumed. I am back to my system admin role. Let me list the task. So I can see this is my task underscore ch15. Right now it is started state and it is scheduled for 60 minutes. So it will run in every 60 minutes, and the definition what it runs is select current user. Now I'm going to create a task ch15 underscore clone using a clone keyword, and I am using task underscore ch15 as a source task. So my task is cloned successfully. Now let's see whether the clone task is having a running status or a different status. here I can see I have a task 15 and I have a task 15 clone. When I go to the task 15 clone, it is right now in a suspended mode and the source task is still running. So whenever a task is cloned, it automatically gets into a suspended mode. So even if you have a lot of tasks running under a schema, and if you clone a schema like pipe, it will also go into the suspended state and you have to explicitly go and resume it. Now let's see what happens when we clone a database which has two schema and many more objects within the schema. So here I have already created the database and the schema under them, and we will quickly review and then perform a database level clone operation. So I go to the database tab, and here I am having a database called ch15 source db. I have 4 tables under 2 different schemas. I have materialized views as well as normal view under different schemas. I have 2 schema alongside information schema and the public schema. Here I have 2 stages under different schemas. These are my file formats under different schemas. Couple of sequence objects and the pipe object. So this is how my source database looks like. And here is a script which is used to create all the object. Now I can check all the object using a show command. I have 2 tables under my schema 1, and that is how I can check everything. Let's see how many stream do I have. So I have 1 stream under my ch01. Now I'm going to clone this source database and create a clone database called clone_db_01. Before that, I would like to see, do I have any databases like this? So I don't have any databases named clone_db_01. Now let me create that and we will see how much time does it take. So my database is cloned successfully. It took 6.44 seconds. Now let's use this database and see how many schema does it have. So I can see I got 2 schema copied to the clone database automatically, and now I can go back to the database tab and validate once again. So here I click on my clone database. I can see all my tables are created. I have schema automatically created. I have views automatically created. I have file formats automatically created. So everything is created automatically, including the pipe object. So this is how database level or schema level copy works. Let's validate whether stream and task are also copied or not. Now I am in my clone DB and second schema. I can see this is my DB01 and the stream is available. So task is also copied under a clone DB and status is suspended. So functions are also copied and procedures are also copied. So this is how the overall database or schema level object cloning works. So how are you feeling now? I hope it was not an overwhelming session and you must have some takeaway from this episode. Now, if cloning can do so much, why Snowflake has a data sharing feature? And is data sharing and cloning are the same concept with the different names? Can I share database, schema or table or all of them? If so, how can I do that? Does it cost a lot? Is it a complex process? To get the answer of all these questions, watch the next chapter. And don't forget to leave a comment and press the like button if you have learned something here. Thank you so much for your time and attention, and happy learning.